Good morning, everyone. Today, I will be talking about our project on Nile tilapia, or known as Oreochromis niloticus. Nile tilapia is one of the most important freshwater fish species in aquaculture. It is originated in Africa, but it is now found in more than 18 countries because of its rapid growth, high tolerance to different environmental conditions, resistance to disease, and ability to reproduce easily in captivity. These characteristics make it one of the most widely cultured fish species in the world. Nile tilapia is also an affordable source of high-quality protein and plays a major role in improving food security, supporting rural livelihood, and contributing to the aquaculture industry worldwide.
Fish meal is high-quality protein source made from processed fish or fish byproduct. It is one of the main ingredients in aquaculture feed because it contains essential amino acid that helps fish grow and develop. Fish meal is high digestible, making it an efficient protein source for many fish species. Besides fish meal, fish oil is also added to fish feed. It is the main source of lipids or fats it's rich in omega-3 fatty acids, which provide energy and support fish growth and health.
Next, I'm going to talk about protein in fish feeds. High protein in feeds. Fish require high protein level for rapid growth, immune development, and strong immunity. It provides essential amino acids that the fish cannot produce on their own. Main source and alternative. Fish meal is the common protein sources, but sustainable options like soybean meal, insect larvae, and microbial protein are increasingly used to reduce pressure on marine resources. Importance in formulation. Balanced protein improves feed efficiency, minimize waste, and support sustainable aquaculture. Quality and digestibility matter more than the quantity alone.
Now we are going to take pellet formulation. First, we need to make our own feed. Formulation: the ingredient is fish meal with flour, palm oil, carboxymethyl cellulose, bentonite, chlorine chloride, calcium phosphate, and vitamin C. At here, the only thing that we change is the palm oil percent and the fish meal percent. So next, we need to weigh all of our ingredients. At our lab, we use digital weighing scale because it is the best option since it gives you accurate reading of the weight of the ingredient. Then we will mix all of our ingredient together. First, we will dry mixing the ingredient at the red basin, and at later stage, we will add the wet ingredients such as palm oil and distilled water. After we are done mixing the ingredient, we will slowly put all of the mixed ingredient into the pelletizer so we can actually get the desired shape for our pellets. At last, after we already shape the pellet by using the pelletizer, we will put it at the oven to dry it out. This is to reduce spoilage and microbial growth, so our pellet stays strong and not spoiled.
Preparation of aquarium and fish. First, we prepare a medium-sized aquarium. Before put the fish, the aquarium was soaked for 1 or 2 weeks. These steps help remove dirt, manufacturing residues, and any remaining chemicals that may harm the fish. Next, we obtain the fish from a hatchery. The fish were carefully caught using a fish net to minimize stress and injury. We select only healthy fish that show no signs of disease. To weigh the fish, we first prepare an electronic weighing scale and a small beaker filled with dechlorinated water. The beaker was placed on the scale, and the tare button was pressed to reset the reading to 0. Then, the fish was gently placed into the beaker. The weight was recorded, and the measurement was repeated 3 times to ensure accuracy. For measuring the fish length, we prepare a rule and a flat surface. In our experiments, we use a chopping board. We measure both the total length, from the tip of the mouth to the end of the tail, and the standard length from the tip of the mouth to the base of the tail. After measuring the fish weight, fish length, and pellet weight, all the collected data were recorded in the Google Excel spreadsheet provided by our lecturer. To maintain good water quality, we change the aquarium water at least twice a week. The aquarium was rinsed using clean water only, without soap or detergent. Before putting the fish, we mix anti-chlorine solution into the new water and allow it to stand for about 5 minutes. After that, The fish were transferred into the aquarium, and the aerator was switched on to provide enough dissolved oxygen. After that, each aquarium was labeled using a permanent marker. This made it easier to identify each treatment group throughout the experiment.
And now, I will be talking about method sampling from week 1 to week 5. Before sampling the fish, all equipment such as nets, measuring boards, weighing scale, ruler, and containers were prepared and clean water was provided to reduce stress, and the fish were fasted before sampling. This helped ensure accurate weight measurements and minimize waste in the water. During the sampling, the fish were caught using a soft net and handled carefully to avoid injury. Each fish was weighed using a digital scale and measured for its total length and standard length. These measurements were recorded every week from week 1 to week 5 to monitor growth. The handling time was kept as short as possible to reduce stress. After the measurements were completed, the fish were carefully returned to their culture tank. Their behavior was observed to ensure they recovered well and continued swimming normally. All equipment was cleaned after use, and the fish weight was recorded immediately in the Excel table provided through Google Classroom. Recording the data right away helped ensure the measurements were accurate and reduce the risk of recording error.
The final sampling for fish measurement is: first one, we need to prepare a cutting board and a ruler. Second, scoop out the fish using hand slowly to avoid stress. Third, place the fish and then measure the fish using the ruler. Last step is, we need to record the fish length in Google Excel, provided by Madam Ross. Next, final sampling for the fish weight. First, prepare a 1 liter beaker and a weight scale. Second, place the beaker that was filled with water on the weight scale. Third, scoop out the fish using bare hand. Move slowly to avoid the fish to be stressed. Fourth, put the fish inside the beaker that were placed on the weight scale. Don't forget to record your data on the Excel.
So this is the result on weight performance. So this is the graph for total weight gain. The way that I get the total weight gain is final weight minus the initial weight. So the initial weight is from week 1 and the final weight is from week 7. And as you can see here, diet 2 is actually way better. So it's actually significantly better than diet 1. So what can we conclude from this? Diet 2 perform better, but the result may be affected by the changes of fish. Some people actually didn't use the original fish because the original fish is actually dead. So they may get a smaller fish than the original, or they may get a bigger fish than the original. So yeah, this graph is actually not that accurate, but it still shows that diet 2 perform better. For the last one, commercial fish meal diet 1 may go through intense heat processing, which denature the essential protein and lipid quality for the fish pellet. So this means that since diet 1 actually use commercial fish meal, the process might actually be the reason that the pellet is not that good.
Diet 2 showed the best performance with a total length gain of 0.54 cm. Diet 1 showed a poorest performance with a total length gain of only 0.02 cm. This means fish feed diet 2 grow much longer than fish feed diet 1. Diet 2 likely provide better quality protein and more digestible nutrients, allowing the fish to grow faster. The National Research Council states that fish require adequate protein and essential amino acid for optimal growth and efficient feed utilization. Diet 1 showed the lowest growth performance, which may be due to lower nutrient digestibility or poor ingredient quality. According to Ben Cross et al. 2007, report that poor quality feed ingredients can reduce nutrient utilization and slow fish growth.
Next, we move to the result of survival rate. Diet 2 has the highest survival rate, as much as 90%. Diet 1 initial number of fish is 21, meanwhile the survived fish only 10. Next, Diet 2, the initial number of fish is 20, and the final number of fish means the survived fish was 18. The poorest performance is Diet 1. Diet 1 had lower survival rate and poorest growth performance compared to Diet 2. Diet 1 provides less suitable nutrients such as protein. As the result, when fish consume fewer amount of protein from the diet, it reduces growth. The best performance is Diet 2. Diet 2 contains more fish meal than Diet 1. Fish meal is the main protein source, so Diet 2 provides high quality protein. Studies have reported that protein has effect on the growth performance of fish.
Based on the overall findings, Diet 2 shows the best growth performance in Nile tilapia. One possible reason is that vitamin C was incorporated directly into the pellet formulation in Diet 2. However, in Diet 1, vitamin C was only coated into the pellet surface after production. Surface-coated vitamin C is more likely to leach into the water before being consumed, reducing its effectiveness. Previous studies have shown that dietary vitamin C promotes fish growth, enhance immunity, and improve overall health. Another possible factor is the selection of experiment fish. As some fish in Diet 1 may have been smaller or less healthy at the beginning of the experiment, which could have influenced their growth performance. Therefore, their Diet 2 that can be considered the more effective fish meal treatment for promoting the growth of Nile tilapia.
Next is the challenges our group faced during this study is the first one, the decrease in fish weight, which showed the quality of our pellet, that is Diet 1 is poor. Second one is a higher number of our fish Diet 1 died compared to the fish Diet 2 due to poor pellet quality or the wrong method of handling.
Future direction for fish feed and nutrition. In the future, research should focus on developing more sustainable and cost-effective fish feeds for Nile tilapia. Alternative protein sources such as insect meal, algae, and agricultural byproducts can be used to reduce dependence on fish meal while maintaining good growth and fish health. Researchers should also improve feed formulations to increase nutrition absorption, improve feed conversion efficiency, and reduce waste. This can lower production costs and minimize the environmental impact of aquaculture. In addition, further studies should evaluate the long-term effects of these alternative feeds on fish growth, health, water quality, and overall farm productivity. These improvements will help make Nile tilapia farming more sustainable and profitable.
Next is the implication of the study. First one, we gain better understanding of the fish formulation. We understand how the different protein quality of Diet 1 and Diet 2 will affect the fish growth rate and health. Second is enhance practical skill in feed preparation, growth monitoring, and do data collection accurately.
In conclusion, this project examines the growth performance of Nile tilapia fry that were fed pellets produced from two different fish meal sources, commercial factory fish meal and processed fish from hatcheries and ponds. During the 7-week study, we gained hands-on experience in making fish feed by measuring the ingredients, mixing them with water, forming the pellets, and drying them. We also learned about the importance of proper fish nutrition, especially the role of protein, vitamins, and minerals in promoting healthy growth. Throughout the project, we care for the fish by feeding them regularly, changing the water, and monitoring their health for any signs of stress or disease. Working as a team allows us to share responsibilities, solve problems together, and improve our teamwork skills. Overall, this project enhanced our practical knowledge of feed preparation and data collection. It's also provided valuable experience in aquaculture and helped us understand the importance of good management practices for successful fish farming.